We're beginning our journey into polynomials and polynomial functions, and we start off with simplifying expressions. But before we do, we need to reflect on the properties of exponents. And I'm not going to go into detail for each one of these right now, but we will as we're moving through this simplification process, go through at least some of them. But just to list what those properties of exponents are, we've got the product of powers, we've got the quotient of powers, negative exponents, the power of a power, the power of a quotient, the power of a product, and zero power. And then as we simplify expressions, we've got certain rules that we have to go by. One, that there are no power of powers. Second, each base appears exactly once, that all fractions are in its simplest form, and that there are no negative exponents. Now, in this first example, we've got 2x raised to the power of negative 3 times y cubed, and all of that is times negative 7, x to the 5th, y to the negative 6. Well, we're going to take this step by step. And our first step here is we are going to multiply 2 times negative 7. Well, we're all pretty comfortable with that. 2 times negative 7 is negative 14. All right, and then we've got x raised to the power of negative 3 times x to the 5th. And this gets us to the product of powers. And so if we've got variables, a variable raised to different powers, each variable, or each expression of a variable, maybe I should say, raised to a specific power, and we're multiplying those, which we would in this case, then we just simply add the powers, and that is the product of powers. So I've got x raised to the power of negative 3 times x to the 5th. We're just going to add those two together. So it's x minus 3 plus 5, and that's going to give us x squared. And we've got the same situation, or similar situation, with this variable y. We've got y raised to the power of 3, or y cubed, times y raised to the power of negative 6. And we're just, again, the product of powers, we're just going to add those powers. Well, let's see, 3 minus 6 is going to give us y raised to the power of negative 3, which brings us to a second property of exponents, which is negative exponents. So here we got this y raised to the power of negative 3. Well, anytime we've got a negative exponent, let me put this up here, y to the negative 3 equals, raised to the power of negative 3, equals 1 over y cubed. That negative in that exponent places that variable, in this case, in the denominator, because technically this is y over 1, y negative 3 over 1. And so it moves it down into the denominator. Now, which then, of course, brings us back to one of our rules. So for simplification, we can have no negative exponents. Well, let's see, we got negative 14 times y squared times y to the negative 3rd power. And to satisfy our rule of no negative exponent in simplifying this expression, we then can finish this off by saying this is negative 14 x squared over y cubed. And we have fully simplified this one. All right, well, let's go to this second one. We got 15c raised to c to the 5th times d cubed over being divided by negative 3c squared d to the 7th. And again, we're going to just take this one step at a time. So let's see, 15 divided by negative 3. Well, we can handle that pretty well. 15 divided by negative 3 is going to give us negative, perhaps I'll do this with a different color. That'd give us negative 5. All right, now, here we go. We got variables raised to different exponents. We got 6 to the 5th, and we're dividing it by c squared, and this brings us to the quotient of powers. So when we got the power of powers, the product of powers, we add the exponent. When we've got the quotient of powers, we subtract the exponent. So c to the 5th divided by c squared, that's 5 minus 2, and that's going to be c cubed. Now let's deal with this variable d. Well, the same thing. We got d cubed being divided by d to the 7th. We're going to subtract those exponents. So let's say 3 minus 7 gives us d to the negative 4th. But again, we've got rules of simplification that tell us we cannot have a negative exponent. And so d raised to the power of negative 4 is the same as 1 over d4. So let's finish simplifying this expression, and then it would be negative 5c cubed over d to the 4th power. Now, you probably don't want to look at a couple of others, but I do. It's great to be king. And so let's move over here to the next slide. All right, now we got, in parentheses, a divided by 4 raised to the power of negative 3. And this actually gives us the two things. It gives us negative exponents, because I got a negative exponent, negative cubed right there. And I've also got the power of a quotient. But when I have a power of a quotient like this, I've got to raise both the numerator and the denominator by that power, in this case, negative 3. So we're employing both the negative exponent rule, and we will in a moment. But first we're going to deal with the power of a quotient. So this would give me a raised to the power of negative 3 over 4 raised to the power of negative 3. All right, well, let's see. Well, a raised to the power of negative 3, since that's in the numerator, that's going to put that a to the negative 3 in the denominator. It's going to flip it down. And then we've got 4, which 4 raised to the power of negative 3. It's in the denominator. It's going to move it up to the numerator. That negative exponent is going to flip that relationship that we see here. So let's see. We got... well, we got to take 4 to the 3rd power. Okay, 4 times 4 is 16. 16 times 4 is 16. Yeah, 16 times 4 is 64. And so this finishes off at 64a cubed. All right, that's not too bad. All right, let's look at this last one. Now, this last one, I've got negative 2x cubed, y squared. That's all in parentheses, and that whole thing is raised to the power of 5, to the 5th power. And this has us utilizing the property of exponents of the product of the power of a power. This is the power of a power. Now, if we're taking a term that's raised to an exponential power, and then we're raising that again by an exponential value, we multiply the powers. Now, if I was just simply multiplying x cubed times x squared, that's x to the 5th. But here we're taking the power of a power, so we're going to multiply that, and we're going to do that to every term. So let's do this in this step. First, we got negative 2 raised to the 5th power. This is very similar to the distributive property. I got x cubed raised to the 5th power. Well, x cubed raised to the 5th power, I multiply those exponents, 3 and 5, so I got x to the 15th. And then I've got y squared, and it also is being raised to the 5th power. So 2 times 5 is 10, y to the 10th. Now, I'm not quite finished because I can further simplify this negative 2 raised to the 5th power. So let's see, negative 2 times negative 2, that'd be squared, that's positive 4, times negative 2, that'd be cubed, that's negative 8, times negative 2 again would be to the 4th power, gives me 16, and taking negative 2 to the 5th power, 16 times negative 2 is negative 32, x to the 15th power, y to the 10th power, and shazam. We've simplified some expressions using the properties of exponents and our simplification rules. Practice, practice, practice.